if the die you're talking about is not fair. So it is unfair and biased die. So suppose it's a die like this, cubic die, and it is unfair and biased. Given that the probability of 6 is twice the probability of each other number. Okay, let me repeat. They are saying this is an unfair biased die. Given that the probability of getting a 6 is twice the probability of getting each other number. So let me list the numbers. So the numbers are these. So numbers are 1, 2, 3, 4, 5, 6. So if the probability of getting a 1 is P, probability of getting a 2 is P, the probability of getting a 3 is P, the probability of getting a 4 is P, the probability of getting a 5 is P, but the probability of getting a 6 is twice of that, twice P. Now, you know total probability is 1, so you add up the probability. So let's add it up. P plus P plus P plus P plus P, 1, 2, 3, 4, 5 plus 2P equals to 1. So now if you add it up, 1, 2, 3, 4, 5, 6, 7. So there will be 7P equals to 1. Therefore, the value of P is 1 by P. So now they're asking you find the probability of each and every number. So the probability of 1 is 1 by 7. The probability of 2 is 1 by 7. The probability of 3 is 1 by 7. The probability of 4 is 1 by 7. The probability of 5 is 1 by 7. Only the probability of 6 is 2 by 7. So that is another type of math where you have a die that is thrown. It's a cubic die, but it is unfair and biased. In that case, whenever they give you a question based on every probability is the same, but one number has double the probability, in that case you write it out and you write down the concept of total probability. We know total probability is 1. This summation means total. So total probability is 1. So hence find the probability that the total is 10. So when you throw this die twice, what is the probability that the total is 10? So total is 10 when we have 5 and 5 or 6 and 4 or 4 and 6. So there are only 3 ways where you can have the total as 10. So now we can write 5 and 5 is probability of 5 is 1 by 7. It's a bit different because it's now 1 by 7, or 6 and 4 is 2 by 7 and 4 is 1 by 7. Same thing, 2 permutation is into 2. So now we can just calculate this probability. So the idea here is this: from time to time you're going to get a die that is not fair, that is biased, and then you just do the calculation. But for doing the calculation you have to first figure out what is each and every probability going to be. Each and every probability is not going to be 1 by 6. So you cannot just assume 1 by 6 unless it's a fair and unbiased die.